In this problem, we have a perfectly symmetric elastic collision. So the mass of each cart is 1.5 kilograms, and they're coming at each other with exactly the same initial speed but opposite directions. So right from the beginning, we recognize that the total momentum of this system is 0. One car has rightward momentum of 1.5 kilograms times 0.5 meters per second. The other has a leftward momentum with the same magnitude, so those add up to 0. Well, this means the momentum at every moment in time is going to be 0 because momentum is conserved. So whatever you consider the final moment in time, your total momentum's got to be 0. If I express that in terms of the speeds of these two objects, I'm just going to call their mass little m for the moment. And then this will be the first mass and this will be the second. I can say the final momentum is mv1 final minus mv2 final, where I've taken care of the direction with that minus sign, and the speeds are v1 final and v2 final. Because these two masses are the same, I can factor m out, set this equal to 0, and I realize that v1 final is equal to v2 final, no matter what the final moment in time is. In other words, these objects always have the same speed. So when we get into part A of the question, compute the maximum energy stored in the spring. The key to this is figuring out what are the speeds of the two masses at this point where I'm at the maximum compression of the spring. And these two masses are moving towards each other always with exactly the same speed. We just figured that out. So where does the maximum compression occur? That's the transition between the two cars moving towards each other and moving away from each other. So where's the transition between moving toward each other and moving away from each other? That's when both of their speeds are equal to 0. Now we take a look at the energy concepts. So in the initial state, I have no spring energy, the spring is relaxed, and I have kinetic energy in both of those moving masses. In the final state, I have no kinetic energy, so all of that energy must be in the compression of the spring. So to get the energy stored in the spring, I just find out how much kinetic energy was there initially, and I know that ends up in the spring. So the total kinetic energy is just the sum of kinetic energy from each piece. And when I add up those two energies, I get 0.375 joules. And I know all that energy ends up in the spring because there's no motion in the final state. So spring potential energy in the final state must be equal to 0.375 joules. That allows us to answer question B, where we're looking for the maximum compression of the spring. Well, I know how much energy is stored in it now, and I know how the spring energy relates to the compression. That's 1/2 kx squared. Our spring constant, we're told, is 50 newtons per meter. So we multiply by 2, divide by 50, and square root the result, and I get a compression of 12.2 centimeters. If you find the physics content on Zach's Lab helpful, click on the Zach's Lab logo on the right to browse playlists and subscribe to the channel. I produce over 100 new videos per month, and subscribing is the easiest way to find new content. Thanks for watching.